Hello, everyone. Um, Welcome to the CTBUH 2011 World Conference. Hope you all enjoy the morning session. Now it's the afternoon session. It's starting the afternoon session. This is the track session number 10, Construction and Facility Management. Our first speaker is Mr. Amitabh Kumar. He is the Vice President at the Indiabulls Real Estate at Mumbai, India, with overall responsibility for the civil construction projects of the Indiabulls Group, about 14.5 million square feet under construction. He has done Master Technology in Civil from Indian Institute of Technology, Kanpur in India. He is a member of American Society of Civil Engineering.
We are presenting the construction challenges faced in the making of this high-rise towers. They are the sky towers by name in Mumbai. So, four towers, sky tower, sky suite, and twin towers of the sky forest.
Okay, so these are the four towers, sky sky tower, sky suite, and a sky forest. Sky forest is having twin towers. These are the project engineers associated with the project and different consultants. I would especially mention JW, the principal structural engineer, and I'm happy that Mr. Joshi and Mr. Vatve is present here. We are getting good guidance from Leslie Robertson Associates. Mr. Bill is also attending this conference. Wind engineering, we have entrusted with RWDI UK and Canada. Facade engineering is done by Arup and other consultants. This is the site plan of building. These are the three plots very adjacent to each other in the central Mumbai. Mumbai is the city surrounded by the sea. This is in the southern tip of the Mumbai, South Mumbai, and this is the central part of the central portion in South Mumbai. And these buildings are ranging from 257 to about 300 meter high buildings. And we are facing a challenge because already these are constructed buildings in the same campus, in this campus, and it is in this campus. So we have to manage with the existing building, and side by side, we have to go on this massive construction. The structural system, we are doing 3D FEM analysis, and we are taking nonlinear construction sequence into account in the analysis. This lies in seismic zone 3 as per IS code, Indian Standard Code, which is SA by G equivalent to 0.16, and we are using response reduction factor of 5. We are doing the wind tunnel test has been done for all the four buildings. And due to changes in the design and in massing, this sky tower has been redone. So out of all the four, sky tower is the more slender structure, and this is the peak acceleration graph for the sky tower. That's why we are putting outriggers for the sky tower, but other three towers, outriggers are not required. So they are founded on 3.5 meter thick raft. And then the sky forest, we faced a peculiar problem. The rock underneath the tower, one tower is on the raft, but another tower is on a pile cum raft due to the variation in underlying rock characteristics. The lateral load resisting system is the central core wall, and then RC peripheral frames and outriggers for sky tower. We are using post-tensioned flat slab. These are the challenges which we are facing. This is a very dense populated area where the construction is going on. It's almost 1 lakh population per square kilometer. The traffic is very high. The peak hour traffic passing through that junction is 5,000 PCU per hour. Local regulations is there. There are a lot of sand shortages due to government regulations. Existing residential towers, which I explained, is also a problem. This Bombay is a very high rainfall zone, and we have to slow down the construction during rains. And there are a lot of design changes just from the inception, and that creates a lot of problem. We are using all newly introduced high-rise construction equipments, and we are targeting a 7-day slab cycle for the construction strategy. This is just an example of the design change. Like if you see, this is the old core layout in the Sky Forest where we are having 4 service lifts. Now it has been changed to 2 service lifts, and these 2 service lifts are emerged as an area serving this lobby for these lifts. We have also introduced many side openings, so twin opening lifts are there. So, and you imagine all this is being done when we have already ordered the core, this SKE 50 and SKE 100 system for climbing, as we are using the core proceeding method. So these are the construction strategy. The main construction technology used is core proceeding method with auto climbing formwork system for the lift cores, then guided climbing system for external RC walls, lightweight panel formwork like Alufix and others for columns and wall columns, generic panel slab formwork with drop head for this slab. We are using concrete placer booms, high performance pumps, and internal climbing tower cranes, etc. We are also putting this edge protection system at the higher level so that the people can work in a safe environment. This is the automatic climbing system, SCP-400 from Dhaka, is being used for the main core of a Sky Tower. In case of Sky Forest and Suite, we are having long core, lengthened core, so we cannot go for this automatic SCP type platform. So there we are using SKE 50 and SKE 100 from Dhaka so that the construction can be in phases. Lightweight panel formwork is also used for these circular columns. Column shape changes to rectangular in residences. For Sky Suite, we are using Maiwan/Kumkang type aluminum formwork system due to special geometry. This is the Sky Tower, and all the formwork systems used is shown here. This is the parking level, and this is the residential level. Similarly, the system is shown at parking level and residential level for a Sky Forest and a Sky Suite. So as I was mentioning you, these are the longest core. So here we are not using SCP, but we are using SKE 50, SKE 100. And this is generic panel slab formwork under use in Sky Tower. The construction sequence to achieve the 6 days or 7 days cycle, we are taking the core walls above. So core wall preceding method is being used. Now we are using isolated walls also we are taking up. In the Sky Forest, there was a peculiar problem due to design change. The construction sequence has been changed. Now the upper deck of our residential floors has lower, and we are using it on a floating column. We are using floating column, and then 8-meter column is constructed. 2 floors is constructed at a time, and this upper deck will be revisited afterwards, and it will be away from the critical path, and this will speed up the progress. The major equipments and their placement is very important to achieve and construct high-rise buildings. So these are the major equipments, and their optimal placement depending on the building geometry and construction sequence, the tower cranes, placer booms, hoists, and concrete pumps. These are the details of the tower cranes. We are using 8 tower cranes on these projects, and depending on the geometry, we have chosen different boom length and other things. Concrete placer booms, also we are using 7 concrete placer booms. So MX32 put miser placer booms are being used. Placer booms generally we are placing inside the core so that in the climbing sequence it will not hamper the progress of the work. These are the location of the tower crane on the plan of the building. This is the sky tower. This one. Here you see the sky forest. Initially we planned for 2 tower cranes, but due to design changes, now we are using 4 tower cranes to handle the upper deck. We will require steel structures and other things. And accordingly, we are putting anti-collision devices in the tower crane. Because they are very dense, 4 tower cranes are interfering with each other. Hoist arrangement is also very important to handle this. In the sky tower, due to geometry, we are putting two hoists, which is taking up to the podium level, last parking podium, and again 2 hoists we are putting from the parking podium to take the things up, because the building is shrinking and the podium is projecting outwards, so we cannot put hoist up to the end. These are the main hoist system which we are using. We are using LMAC hoists, and roughly 1 meter per second, that is 54 speed we are using. Climbing sequence of the equipments is very essential to control during the speed of construction, because if climbing sequence is not achieved, then we will not be able to lift the core wall up. So all the tower crane climbing and the MX32 concrete placer climbing sequence has to be synchronized. The story height is varying sometimes, so that also has to be taken care in climbing sequence. Erection of equipments is also very challenging. Here we are seeing the photographs from a sky tower, where we are using a 300-meter crane to put the concrete placer boom, because that time the construction has already been done up to a certain height. Concrete planning is very essential and very critical. We are roughly require about 0.5 million cubic meter of concrete for these 4 projects. So we are having 2 in-house RMC plants which has to be shifted because it was coming on the building geometry. So now it has been shifted to other side, and we can't produce all the concrete in the in-house plants. So we are also taking from outside RMC suppliers, but what we are doing that high performance concrete we are producing ourselves, and lean concrete like M20, M30 we are taking from outside sometimes. Mixed designs is very variable, keeps on changing, especially when we achieve the shortage of sand, then we have to experiment and change the mixed design to take care of the variability of input characteristics of the sand. This depicts the concrete grade used. Then concrete pumping, this is the typical for a sky tower. This is showing you the location of plants. Here is the RMC plant, just 2.5 kilometer away from the site. These are the pictures of construction, under construction. This is a sky tower, come up to about 20th level, 100 meter of height. It has already achieved. These are the other two towers. They are just reached the ground floor, but all the major equipments have been installed. So I would like to conclude that high-rise like a sky towers needs careful planning for equipments, formwork system, concrete planning, and construction sequence, as well as site logistics. Wind tunnel study plays very crucial role during design phase. The design changes after onset of construction poses a big challenge, but at the same time, this challenge has to be taken dynamically, and decision making has to be very fast. We cannot afford of not taking the decision. Change, especially if there is change in core, it's a nightmarish and very difficult to handle the core, any design changes in core. These are the references from which we have derived some. Thanks.
So now we are going to the 5 minutes questions, and if anybody from audience have a question, please. So no more question. Okay.
Okay.
So thank you, Mr. Kumar.
Thanks.